We're fine. That's good. You know.
27. Day 27 is graphing. We're actually going to graph two different functions, but it doesn't matter. The transformations apply the same to really any function. Talk about the basic shape of our functions. And it's not day 8. The days changed. It's day 27. The parent functions tell us the basic shape. And then we're going to graph thinking about what we do to x. So for both the parent functions, you're going to start at 0, 0. Are y'all ready? Okay, both functions, you will start at 0, 0. Most parent functions, you do start at 0, 0 or somewhere around the origin. We're going to start at 0, 0. And square root functions, the way I remember the shape of a square root function. Hello? Yes.
Well, that's bad. It tastes like the
Oh, yes, no, was with me. The reason why I couldn't say she was is because I just got a new roster today. And so I had old students on my roster that they didn't come to me because they're not on my roster. And new students got added today during the day. So she just got added to so she was on my roster in Skyward, not on my roster in Raptor. Maybe it uploads every night. I don't know. So there's probably a couple students that were with me that didn't get marked present because they weren't on my roster because they didn't match. Yes. Yes. All right. Thank you. Bye. Okay, sorry about that. I was about to say something really profound. I just know it. So the square root graph, the way that I remember that shape, the shape is like the symbol. So the shape, you've got the square root symbol, and the shape of the graph is kind of like that, kind of like this symbol. It kind of goes like that symbol. That's the square root shape. A cubic function has a shape a little different. Its shape is like that. And to make these graphs, to make the square root function, we have to think about perfect squares. So that's something that you can take the square root of and you get a pretty whole number. And so the first one that we kind of overlook is 1. What's the square root of 1? 1. Okay, so the first thing that I'm going to do is move over. So the square root of 1 is 1. So I'm going to go up 1. Over 1 and up 1. The next perfect square is 4. What's the square root of 4?
2.
2. So now I'm going to go back from the origin, back from the starting point, and I'm going to go over 4. The square root of 4 is 2. Does anybody know what the next perfect square is? What's the next number that I could take the square root of and it would be a pretty number? 9. So if you have enough room, you could also go over 9 and then up 3. So this is how we get the shape. Woo. I'm going to try that again. It didn't come out as curvy as I would have liked it to. It looks like this. It is a curve. And typically, these are the only 2 points that we can add. Like sometimes you can go over 9 and up 3, but a lot of times it is just over 1 up 1, over 4 up 2. And that has to do with square rooting. The cubic function, well, we're going to cube things. We're going to multiply a number by itself. So we're going to start with 1. If we go over 1, what's 1 times 1 times 1?
1.
1. So I'm going to go over 1 and then up 1. Okay, if I go over 2, what's 2 times 2 times 2? 8. So then I'm going to go up 8 and I'm already off my graph. It's way up here. And these have this shape where they reflect. it's kind of reflected. So it's also going to go over here, -1, -1, and then it would be -2, and then -8. Be way down there. So now when I connect the dots here, it's not like just a straight line. I have to kind of curve through. So I will go like that and then curve down like that. So these are my basic shapes of the square root and the cubic function. Next, let me move this down a little bit. Transformations, these work the same for every function. They work the same for a quadratic. We've already had something that looks a lot like this where we have A, H, and K, and those move my graph. They're going to be the same movements here. And so they work the same for every function. It's important to take note of that. This is my basic equation for square root and for the cubic function. These are like placeholders for when things happen. So these transformations, it can actually have two different transformations. It can reflect over X. Or it can stretch or compress the graph. Okay, and that's vertically. So it can stretch or compress your graph vertically. H will move you left and right. But it's really important to note that it's going to move in an opposite direction. Okay, it's always opposite. So if you see +2, that means you move to the left. If you see -2, it means you move to the right. Okay, it moves left and right in an opposite direction. So anything that's with this X grouping, it moves in an opposite direction than you think. And that's because there's a negative in the equation. So it says opposite. K will move you up and down. H and K for a square root. It is the starting point. H and K for a cubic is the center point. So for a square root, it's the start, and for a cubic, it's the center. And you can add words to these if you want. That is your horizontal movement. And this is your vertical movement. So H is a horizontal movement and K is a vertical movement. It is exactly like quadratics. In fact, if you look on the back wall, that is a pre-cal function. It's sine and cosine, and you'll see that there's still some of the same pieces. Now we call HC, but I mean, it's the same. There's placeholders just the same. All right, let's do some stuff. First, it says describe the transformations. Don't overthink these. We're going to move through the equation left to right. Anytime that there's a number or out in front a negative sign, we're going to describe it. So a 2 out in front, anything out front stretches or compresses. So we're going to say, yep, that's a stretch by 2. And then next, we come to the -3. -3 moves me where? Right 3. And then the +1 moves me up 1. These are almost identical to questions we had when we did quadratics. The negative, what does that negative out in front do? Nope. No, it does something. Reflect over X. What? Good. Okay. Sounds good. And I'll let you know, I'll send on the essay when I get word back. I'll respond to you by email. You're welcome. The +2, what does the +2 do? Left 2. I'd like to hear more than just Aiden. And then what's the -4? Down 4. Good job. Here, what does the minus out in front tell me? Reflect over X. Reflect over X. And then there's only one more transformation. What does this +1 tell me? Up 1. Good. Good, good, good. Bless you. What about the 3 out in front? What does it tell me? Stretch by 3. What next? What does this -1 tell me? Right 1 and then down 3. All right, it's important that we know how to look at an equation and to tell all of the transformations verbally. That's important. You have a question on your quiz, you have a question on your test, you have questions on your homework that are exactly like that. You have to be able to do that. But when we graph, what's really important is that we can look at the equation and we can identify what H and K are. This is really important. When you look at an equation, you have to be able to identify HK. So for this one, H is going to be opposite of -3, so it's going to be 3. And then K is 1. So it's always opposite the X value or opposite the H value. So this one's going to be -2, -4. These are really important because it's either the center or the starting point. The next one, what if there's no number with the X grouping? 0 and then 1. What is going to be my center point for this last? 1, -3. When we did that section, when we described the transformations, did we identify whether it was a cubic or a quadratic? Did we even talk about that? I didn't say either of those words. It doesn't really matter. All of the transformations work the same. So next, we're going to talk about which type of function it is because it says describe the transformations and write the equation. I don't know that it's really important that we look at these graphs and we write down in words what's happening. But what is very important is that we can look at those graphs and we can identify what that center point is. That is really important. So for each one of these, we need to look for our center or starting point, and we need to write that down. That is a vital part of our equation. So I would like for you to look at all 3 of them, write down the points. I'm going to do the same, but you should be able to write these points down on your own. Yes.
Trayvon, have you tried this Mountain Dew, bro?
No, I haven't.
Bro, imagine liquefied Jolly Ranchers, bro.
It's good
It's,
or not good?
there's so much sugar.
Mm.
It's 46, it's 91% sugar.
It says 91%.
Yeah.
Oh, it's 91% of your daily recommended sugar, all in one 12-ounce drink.
Yeah, it says 46 grams.
That does not sound good to me. I don't drink soda. I don't like it. It's too yuck. Do y'all agree with my center or starting point for all three of these? Yes, no? Do we agree? Okay, it's the end of the day. I make mistakes, so I just want to make sure we got the same thing. Next, what we need to identify is if there's any kind of reflection. And reflections happen if reading our graph from left to right is your graph pointing down. And so the first graph looks to me like it's pointing up. It's positive. The second graph, from my center point, it points down. So this one, it's important that we need to identify that it's reflected. So there's a reflection. Okay, and then the last one, from my center point, I am pointing down. So this one is also reflected. So when we make our equation, we need to remember that it'll be like this, that I have a negative here or a negative here, depending on what kind of equation. Stretching. Here's how we figure out if there's any kind of stretching. Both of the parent functions go over one, up one, no stretch. This one goes over one, up one, no stretch. When you go over one, if you go any other value besides one, then you're stretched or compressed. And so that's how you can check for a stretch or compression. You have to go over one, up one. If your graph lives there, then there's no stretch or compression. So double checking that for this one, I go over one, up one. No stretch or compression. This one, I go over one, down one, no stretch or compression. Here, over one, down one, no stretch or compression. And so that's what we check for. If you went over one and down two, it's stretched by two. That's how you figure it out. All right, so for my equations, I have to know if it's either a square root or a cubic to know how to make my equation. So what I'm going to do is I'm going to set up the basic form of either one of them, leaving a little space for A, H, and K. What type of graph is this? Square root. And I remember because the shape is kind of like the square root shape. And so I'm going to set up f of x. I'm going to leave myself a little space, square root, and I'm going to put an x in there. So I have space to put an A, an H, and a K. I'm going to do the same thing for the next. Well, I can tell you this is also a square root shape, so I'll write that one. So I've got f of x equals space and then the square root of x. So I've got a space for A, H, and K. This one, it's a cubic because these are square roots. So I'm going to have f of x is equal to space, and then I'm going to have x cubed. It's a cubic. So either type of function, I have a space for A, H, and K. And now I just plug in what I know. So for the first graph, there's no reflection. There's no stretching. So all I have to do is plug in my starting point. So remember that everything with the H is opposite. So I'm going to plug in +3 and then +1. For my second equation, I reflect, so I need to have a negative out front. There's no stretching, so all I have out in front is a negative. For my H and K, I'm going to plug in -1, 2. So -1 and 2, +2, sorry. And they go in that order. For the last one, I'm also reflecting, no stretching, so I have a negative out in front. And when I plug it in, I'm going to plug in +5 + 5. So +5 and +5. I just made equations. So when you're struggling, remember that for starters, you need to identify the center or the starting point, and then you can set up the equation, what I have in black, and you just fill in the space for A, H, and K. Beautiful. Moving on. Next, you have to be able to go the other direction where I give you words and you give me an equation. So I give you words and you give me an equation. So this one, I'm not even going to look at the words yet. All I'm looking at what type of function it is. So the first one is a square root function, and then a cubic, and then a cubic, and then a square root. So if I have to write an equation, I'm going to start by putting in like the template for an equation. So this is the same thing I did when I was writing an equation from a graph. So the first one's going to have f of x, and I'm going to leave myself a space for a, and then the square root of x. Second one, I'm going to have f of x, and I leave myself a space, and then I put the cubic. The next one is another cubic, so I leave myself a space. And then I have a space for h and k. For the last one, square root. So this is my basic template to make an equation. Space for a, h, and k. Whether it's a square root or a cubic, a, h, and k. So reading through here, the first one says stretched vertically by a factor of 3. Where do I put the 3? Yeah, so it's going to go out in front. Stretched vertically. Goes in front. Right 2 is 2 inside, right? And then how do I say down 1? Minus. The only one that changes is left and right. That's opposite. Okay, we wrote an equation. Next, reflected over x. Out in front, we put a negative. Shifted up 5. Outside, plus 5. Nothing. So if you'd like, this can always be turned into, and you may see it like this, negative x cubed plus 5. These are the same thing. So I always leave myself a space because something might go there and I just get myself a template. But if you want to close it up, usually if there's nothing in there, you'll see it like this. So next, we've got a stretch by 1/3. We've got 1/3 in the front. Left 5. Plus 5 inside the x. Plus 5. And then down 4. Minus 4. And last, reflected over x and vertically stretched by 4. Reflect over x and vertically stretched by 4. Minus 4. Minus 4 in the front. And then shifted right 5 units. Minus 5. Okay, we good so far? Awesome. The ones on the homework look very similar. However, they are different. They're different functions. All right, let's keep going. Now we're going to actually graph. To be able to graph, we need to know a couple of things. I usually just scan through the graphs and I get myself an idea of the shape of the graph. And so I also take note of anything that is negative. So this first graph, it's positive and it's going to have the shape of a square root. So I'm just going to jot down the shape. It's going to have the square root shape. The next one, it's negative, but it's going to have this square root shape. So it's going to go down. The next one, it's negative, but it's a cubic. So this one, instead of going from left to right facing up, from left to right, this one is gonna face down. And then the last one, it's also a cubic and it's positive, so it's gonna face up. And I like to identify the shape first because when we identify transformations, everything is really the same for a square root or a cubic. So first I want to identify that shape. So when I go to put the shape on, I know what shape to make. Next, I'm going to identify for each one of these, I'm going to identify the center or starting point. And so for this one, what would these are going to be starting points. What's the starting point for this one? -5, 1. What about for B? I hope somebody else knows these. For C, 0, 1. And for D. Brilliant. Okay. Now I am ready to actually put on my center or my starting point for all my graphs. So the first one, -5, 1. For my next one, -2, -4. Zero, 1. -1, sorry, 1, -3. All right, from here, every single one of these graphs, because none of them are stretched, is going to have its first point to the right one and up one. Every single graph to the right one and up one. That's how they all will start. So I'm going to have, don't just start copying me. Some of them are going down. I know I messed that one up. I messed that one up. So this one that is negative, I go down. Sorry, it's always going to be over 1 and 1, but this one's going to go down. And then this one too, I go over 1, but down 1. Good catch. And then this one, I'll go over 1 and then up 1 anytime it's positive. All right, I'm ready to sketch on my graph by putting some points. Anytime I have a square root, I'm going to go over perfect squares. So for this one, I'm going to go over 4 and then up 2 because the square root of 4 is 2. So over 4, 1, 2, 3, 4, up 2. And then next I'm going to see if I can go over 9. I think I can because I can go 5 and then 4 would be 9. So I'm going to go over 9. And then the square root of 9 is 3. And then I will connect the dots. The next one, I can go over 1, down 1. The next perfect square, over 4, down 2. So remember, we want to go perfect squares. I don't think that I can go over 9. 7, 8. Oh, maybe I can. So 2, 4, 5, 6, 7, 8, 9, and down 3. My next graphs. So this one, it's always going to be a diagonal line of points. And then from here, if I go over 2, I could go down 8 if I wanted, but I think that with 3 points, you have enough to create your curve. My curve went crazy towards the end. The next one, I'm going to have a diagonal line. So since I have 1 point here, the other point will go down here and it's going to end facing up. Maybe I should do it in 2 pieces. Yeah, that one looks way better. The last thing that we have to jot down is the domain and range. What's really nice about a cubic function is that both the domain and the range is all real numbers. So for a cubic function, easy peasy. You are facing up and down, so you got your range is all real numbers, and this continues out forever. So it's all real numbers in the left and right direction. So domain and range for cubic functions is always all real numbers. For domain and range of a square root, it is going to depend on the x and the y part of my starting point. Domain is always going to be an x. Range is always going to be a y. And the number that goes here is the number from the x and the number from the y. And then we're going to come back and we're going to put the symbol. So I'm going to have -5 and 1, -2 and -4. So the domain and range for a square root is going to depend on your starting point. For my domain, if this is my start, my graph is greater than that. It's on the right side, so it's greater than or equal to your x value. Or it's greater than or equal to your start. Same thing here. It's on the right side. Really, for everything that I'm going to make you graph, the domain is always greater than or equal to. For the range, when your graph is above the starting point, you say greater than or equal to. When your graph is below the starting point, it's less than or equal to. That is it. We're done. Mm-hmm. Domain and range. Mm-hmm.